AGI can be achieved with the current architectures. And one of the fundamental roadblocks to AGI has been solved. And that roadblock is reasoning. So this is a pretty big statement. This is not just coming from me.
Pretty different than the GPT models. We have these 5 levels of AI we talk about. The first was chatbots. The second, which we've just reached now, is reasoners.
This is the first time ever where I felt like we actually know what to do. Like, I think from here to building an AGI will still take a huge amount of work. There are some known unknowns, but I think we basically know what to go do.
Which is ASI, super intelligence, is actually thousands of days away.
Maybe. I mean, that's our hope, our guess, whatever. But that's a very wild statement.
Yeah. Tell us about it. I mean, that's big. That is really big.
I can see a path where the work we are doing just keeps compounding. If we can keep this rate of improvement or even increase it, like, that system will be quite capable of doing a lot of things. I think already, even a system like O1 is capable of doing like quite a lot of things.
Of course, a CEO is going to stand behind his own product. But just given the behavior of Sam Altman before, he's not being unrealistic in his expectations. He was always apprehensive, more apprehensive than needed sometimes. He didn't want to overstate his case. But he's very confident now. I felt that shift in his demeanor. And this ever since O1. See, before he's always been talking about that the current models are not AGI and they will probably not be AGI. And they need a fundamental breakthrough in order to get there. The way he speaks about it now is that they see a clear road ahead to AGI. In other words, O1 is that breakthrough. O1 solved reasoning according to Sam Altman. And they're going to move on to level 3 now, agents. Now, not everyone is sold on this yet. I wasn't sold on this either. Of course, we don't have the best models. They have more information than we do. But just from O1 preview, the difficulty of tasks it's able to solve in one go is insane. It really does impress me. And I've seen other use cases where it even solved novel problems, where it was truly innovative. But of course, it's all empirical. Could we understand theoretically why O1 is so good? From the perspective of human reasoning, it's easier if the model functions similar to humans to be able to predict that it will be as good as humans. And for most people, it doesn't feel intuitive that O1 is similar to human reasoning. But I think it is, and I will elaborate on this using System 1 and System 2 thinking from thinking fast and slow, 2 concepts, where System 1 is the quick thinking, it's intuitive, while System 2 is the slow thinking. It's when we have to reason about something, and something's more difficult. So let's start with System 1 and how older models are similar to System 1. And then we go on to talk about O1, how this fills in the gap of the System 2 reasoner. So first off, what System 1 is what we use when we don't think about things. Like when we're driving, it's impossible to think about everything. About how to change your clutch. You're not calculating how quickly you're going and where you'll be in the next second. You're basing everything on intuition and previous experience. These old models are so similar to System 1. And it's so important to understand it from this perspective in order to correctly evaluate these models, because people are underestimating it. They're saying, oh, it's not that smart because it's giving me these dumb answers. But how many humans give a dumb answer when you don't allow them to think? Just to illustrate this point, when I give a 2-paper essay to GPT and I ask about his opinion on this paper, he gives it within a second. No human is able to do that. And of course they have architectural differences that allows them to do this. They are able to take in the input data in a parallelized way, just like we take in vision in a parallelized way. So we can speak on an image within a second when we don't have to look at it pixel by pixel sequentially. Large language models can do this with text. And they can take in everything in one go, which allows them to be quicker. But apart from this, they're also responding quickly because they're not thinking. They're not using test time compute, meaning they're not using energy during the time that they're solving a problem. They're just giving an answer instantaneously. So if you want to compare humans to AI, you have to compare humans to AI with the same kind of constraints. Let both not think. Let them both run on System 1. Performance-wise, models obliterate humans on System 1. GPT-4 intuitively is very good. And there are not a lot of tasks humans are better at. Now, considering that these are system 1 models, psychology is the same. Do not ask O1 for an opinion on creativity. Ask GPT-4, and even better, ask GPT-4 to specifically not give a chain of thought. Just give the answer immediately. It will respond intuitively, which can be better for some creative tasks. Now, also, just like humans, they can generalize to new data they have not seen before with system 1 thinking. For example, take a doctor. When he's seen many patients, a new patient can come in with a set of symptoms he's never seen before in that combination, but because he's seen so many patients before, he still has a sense of what diagnosis might be. He has this feeling, right? This intuition. And models do the same. I've covered generalization of models a lot. It's clear from evidence that they do generalize. But the question is to what extent. Seeing it in the light that they are system 1 thinkers is quite reasonable to assume they don't generalize well outside of distribution. And that's in line with the evidence from the literature. So just like humans, we need a lot of data to get an intuition, and they are able to generalize. But just like humans, our intuition is still limited to the data we've been trained on, to our experiences. When something's truly novel, we need system 2 thinking. We need to reason. And that's something these older models don't do. That's why they don't generalize well outside of distribution. When you give them a novel problem that's truly novel, they won't be able to solve it. They won't be able to do science because of that. But now comes O1. And this is a different paradigm. This is how OpenAI has been calling it. And it took me some time to intuitively feel that it is, but it is a different paradigm. Simply because what they are doing is reasoning. And that's a pretty big statement, because what is reasoning even? See, reasoning is when we generate sequences of data in order to build a bridge from what we know to what we don't know. That's just exactly what these models are doing. They are generating data, which is their chain of thought, to get to what they know to what they don't know. In other words, they're able to simulate data around a problem that's outside of distribution. And by simulating data around it, they make it in distribution, in a sense. This is similar to what humans do. When humans get something out of distribution, when they see a physics problem they haven't encountered before, they have to think about it. They have to think, generate data, make a simulation around this data, and then they are able to solve it. Just to give you an example, say I ask you what the energy is that will be transferred to the ground or to heat when I drop a ball from 1.5 meters, and this ball is a kilogram. Now, you can calculate this, right? Just because you probably done calculations like these before, you know which formulas to use. That's system 1, you're using intuition. But now I ask maybe something more difficult. I ask, what's the force applied to the ground when I drop a ball from that height with that weight? And now you have to think about it. Can I even calculate the force to the ground? Well, let's simulate it. Let's simulate dropping a ball and it hits the ground. And as it hits the ground, it's going to apply force to the ground. We can almost feel it. But as this ball hits the ground, we can see that it doesn't just stop immediately. It gets squeezed a bit, and the force applied to the ground is therefore gradually added to the ground. It's not instantaneous. Therefore, we know we probably need a formula about the elasticity of the ball before we can calculate the force being applied to the ground over time. This is an insight, not from prior knowledge, because we might have not solved a problem like this before, but just by simulating it, we can envision that the force to the ground is going to be dependent on how quickly this ball is being squeezed, how quickly it's going to be transferring energy. So we had the knowns, right? We had the weight of the ball, the height of the ball. We had the question, which was, what's the force? And then in order to solve this question, which was a novel question outside of our training distribution, so to speak, we generated data. We generated the simulation of the ball falling, and it hit the ground. And that gave us an insight that allowed us to answer the question. So we used a generation of data, producing a chain of sequential data in order to go from what we knew to what we wanted to know. This is what's happening when we are reasoning. That's system 2. Now, can models do this? They cannot visualize a ball falling like this because they're limited to text. But we can also limit our reasoning to text. For example, blind people can reason just as well. They're able to generate data, but the older models are not allowed to use the generation of data to solve a problem in real time. We can ask it to do chain of thought, and it improves the accuracy of the model, but it's not trained to use chain of thought effectively. That's something we do. We are trained to use chain of thought effectively. Because when we make a mistake, we can look at why we made that mistake. We can look at the steps involved that caused us to make this mistake. Oppositely, AI is trained using reinforcement learning by human feedback. So when AI makes a mistake, a human will tell it, that's wrong, but it won't know why it's wrong. It's the same as you make a test and you get back your grade, but you don't know why you got this grade. You don't know what mistakes you made. You just get your grade. Of course, if you make a lot of tests, at some point you're going to see a pattern, but it's going to dissipate much more slowly than when you actually get to see your reasoning steps and see what you did wrong, when you are able to evaluate on it. And that's just not how they're trained. Until O1. Because O1 utilizes the generation of data of these models. It utilizes what they already know, their system 1, their ability to predict. And it utilizes it to generate chains of thoughts and then have the model evaluate these chains of thought, see which ones are correct, which ones are logical. And when the answer produced from this chain of thought is incorrect, is able to reflect on it and see what it did wrong and learn from that. That's exactly what humans do. There is no difference. We make reasoning this mystical thing, this thing that's ungraspable and we cannot possibly understand it. But this is a very simple perspective, but it's quite accurate. We generate data to go from what we don't know to what we want to know. And so we make out-of-distribution problems in distribution. And these models were not able to do this because they were not able to utilize test time compute to go from the problem to the answer. And now they are able to. And now they're trained to utilize this well. This is the paradigm shift. This is what makes Sam Altman confident enough to say, we solved reasoning. Because this is not just a party trick. This is fundamentally similar to how humans reason. It's not that different. What is the fundamental difference between O1's reasoning and human reasoning? And what is the fundamental difference between System 1 reasoning from the older models and System 1 reasoning from humans? Performance-wise, they're going to increase and they're going to get better. They're comparing O1, the one we have right now, or the one they have, to GPT-2. So if we compare GPT-2 to GPT-4, that increase is insane. So extrapolate O1 to an O3 we have in the future. Now can you feel it? That's a shift. That's enough. This is why they're saying this is what we needed. They don't need much more. They don't need another breakthrough. And I'm sure they will have another breakthrough and another way of thinking about things. But this is really key to reaching AGI. We have a clear road ahead of us. Quite a straight road. We're just going to walk down it. You might have doubts. You might still have questions or things you notice about the difference between models and humans. Like, for example, we actively learn. We are able to learn in a moment while models don't. But this is not as much of an architectural limitation as that it is a design choice. Because OpenAI wants to keep training controlled. They don't want the model to learn nonsensical data from users. So they train it on specific runs instead of continuously. This is also easily solved. We can fine-tune models on the data in the chat. This is a way that ArcAGI challenges are solved right now. When they get a new Arc problem, they fine-tune the model on the input from this Arc problem. And they generate data around this Arc problem and fine-tune the model on that as well. So they fine-tune it on test data, on new data in the chat. We can do this as well. We can just fine-tune models on the data in a single chat to make it actively learn within the context of the chat. So I encourage any comments that want to criticize this. And please do. Please be critical. I love to hear a good argument against this. But if it is true, then OpenAI resolved the biggest roadblock to AGI.